Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon, back with another testing video. Imagine that. Um, if you've watched my last video, I presented a testable command robot template. Really, it was a hello world example where I demonstrated automated testing of using JUnit and Mockito of commands and subsystems and it was built against the what I lovingly called the untestable command robot template, which is generated from the alpha version of the WPI VS Code plugin. What I didn't do in that video, and I kind of view this as a requirement to sort of do all of at least what I had in my head that I wanted to do, and that is I also want to be able to test command groups. Good news is I was able to do that, and this video I'm going to show you how. I noticed, and I got a very nice reply from one of the, I guess, head folks at WPI on the work that I'd done so far, and he encouraged me to, either fork and or put in issues in the ticketing system into WPI repository. So rest assured, once I get done with this video, I am going to go do that. So that everybody, can at least see what I've done, and WPI can decide whether they want to do something with it or not. There is a ticket out there, Lo-Fi Sim master ticket, which sort of kind of addresses the work that I'm trying to do. So I'm going to put my stuff on this ticket. Let's go look at code. So the prior video talked about my hello world example, and all my hello world example did is when you push a button on the LED, or a button on the controller, an LED flashes. So in this example, we want to make it a little bit more complicated because we want to test command groups. So I decided to just, I wanted to now create a subsystem that would flash an LED, but it would also have external stimulus so that you could punch a digital input, and when the state changes, my LED would stop. It's pretty simple. But then what I want to be able to do is hook my, I'm going to call it a silenceable say hello before my say hello that runs forever. So once the digital input is toggled, the flashing LED flips to a second flashing LED. And then I want to write an integration test, a JUnit integration test that proves that, when I make external stimulus to the digital input, that, that the LED flips over like it's supposed to. So in order to do that, you have, things become more complicated, right? You need the benefit of the WPI scheduler to deal with the fact that there's a command group and it's got a sequence of commands and it needs to execute them in sequence and all that stuff. Because for test harness purposes, I don't want to write that stuff. I did in my last video. I wrote a command scheduler, but it's very, very simple, just for the purpose of unit testing. And I like it because it was good for that purpose, but I don't have to rewrite certainly what WPI has done. So we want to use that potential problem that exists in this big framework. There may be dependencies hooked onto it. I don't know what they are. Did they intend for it to be run that way? I don't know. So, I had to do a lot of research and digging to figure out if that's possible. Good news is, yeah, it's possible. So it's very nice. So let me digress for a second. I put out a thread on Chief Delphi about the problems with using the current command robot template from WPI, the VS Code template, at least currently as it stands in its alpha phase. Now, full disclosure, I haven't installed the beta version. They may have changed it and improved it, and then if so, great. But at least the alpha version sort of follows along, actually, with the recommendation, if you will, that the Eclipse code generator did back when, where it encouraged you to use global state and bind up your classes and make things not testable and whatever. So there's a person on Chief Delphi that said, well, testing to that thread, that person said, well, testing is just not, it's not a thing in FRC robotics because things change all the time. It's a very short compressed window, and things are so massively rapidly changing that tests just either there's no, I'm not sure whether he meant there's no time to test, or the second that you write a test, that test no longer is applicable because your underlying class has changed. Whatever it is that he meant, I don't know. But to that, here's my response. So if you watch my last video, I tested the heck out of my Say Hello or my Hello World classes. So now I have this new requirement. My old subsystem, my old Say Hello World subsystem, all it had in it was an LED, and it flashed forever. When it executed, well, actually, this is my subsystem. All it had was an LED, and that's it. And it had a turn on, turn off, and toggle. That's all. New requirement now is I want a subsystem that actually responds to external stimulus. So when that stimulus flips, that the LED turns off. So I need a new subsystem that not only has an LED, but it's got digital input. Am I going to go into this subsystem now because I have this new requirement? Am I going to go into this subsystem and rip it up? Heck no. Why would I do that? This thing is tested. It's a new requirement. I've got object orientation. Let's just extend this thing and write some new tests. So that's what I did. Here's my new subsystem. I call it Silenceable Hello World Subsystem. It's got a new digital input in it. It's got a silencer. It's got a new constructor, right? I mean, I still need to grab my digital, my LED for the output, but now it's got a silencer input. Again, I call into my old constructor. I know it works. I check for nulls. Again, if you remember last video, I have this invariant about making sure everything, all of the member variables are filled in. I add a new method, be silent. Great, be silent. That's all I want to do from a subsystem standpoint is know whether my digital input has now been flipped. Does my digital input say be silent? That's all it exposes. Okay, command, same thing. I got a new command. I inherited from the old command, right? I, of course, now need a new constructor that takes my silenceable Hello World subsystem. So here that is. And then what do? So in the old command, is finished just always return false because it never finished. Now in this case, is finished now needs to know whether or not stimulus has been made to be silent. So that's all I do. I return it here. Correct. I mean, so testing is valuable because now all that old testing that I did to all those old classes, it's all still good. It's all valuable. I'm still going to run the tests. I should now write some unit tests for these classes. I'm not going to in this video. I might for the example because I have added some functionality. So should unit test, should integration test, right? Or not. You could say no, don't need to. But I definitely want to write now an integration test here. And here's what I want to write an integration test for. I now have a say hello intern command group. What does this do? It adds my two sequential commands together. I run the silence, say hello until silence command, and then I run my say hello command, which flashes forever. So now I want to write an integration test that tests whether or not I've done this correctly. Do these things integrate properly? Does this whole thing integrate properly together such that when this thing gets stimulus, this thing comes on? How do you do that? So there is now in my test directory, command group subdirectory. And I'm going to close this stuff up so I don't get myself confused. So here's now my say hello intern command group integration test. Yeah, I know it's verbose. I could abbreviate. I don't know. Sometimes the verbosity just makes it so that you know exactly what it is. Right here. If you watched my last video, you knew that I was running a mock scheduler to test the commands because the command execute method calls, and so to test any command properly, you have to simulate running that. Except this time we're running the WPI scheduler, not my mocked one that I did. So I did essentially the same thing. I created a WPI scheduler test helper, but in this case, I'm calling a WPI version of it. Let's go look at that quickly. What does that do? First of all, I had to figure out how to call it. So I went into WPI and looked. They are actively working this year on testing for the framework in much more significant ways than they have in the past. And they have command tests out there. And so I went and stole how they did it, right? And don't want to have to figure it out for myself. What are they doing? So I basically use that as the template. They remove all commands. They enable the scheduler. So I have in my constructor doing that thing. I have a heartbeat. So how often do you want to run the execute method? 20 milliseconds, I think, is the default. So that's what I default to. I believe that to properly clean up, you should disable and close. I actually didn't see that in their code, but the methods are there. And full disclosure, I am able to run my tests, but when I run my tests in through the runner helpers, like when you click the run button on my tests, run hangs forever. I don't know why yet. I think it's because something's not getting cleaned up. I intend to find out, but I thought putting these things in here would make that stop, but it didn't. And then, so the method that actually pumps the scheduler, that's this one, run for duration. Basically, I just call scheduler run, and I sleep the requisite number of milliseconds. And based upon the duration that you pass in, run for 1 second, run for 2 seconds, it'll pump the scheduler for that amount of time. So the cool thing is, at least at this level, that's all I had to do. Now, to actually instantiate this sucker and get it to work was a whole lot more work, and I'll talk about that in a minute. But just know that it actually does work. So that's really cool. Okay, so to make the test work, what all is this test going to do? So again, actually, let me back up. So because the scheduler, the WPI scheduler now is working, to make it work, you have to bring up the HAL, the hardware access layer. That's the thing that kind of, that's the thing that sits between your robot program and the actual hardware. When you run it on the RoboRio, there's a RoboRio version of the HAL. There exists, and there has existed, I think, for some time, a simulator built in for WPI where you could run the I think it's Gazebo. You could run Gazebo and drive your robot around on the simulator and probably even feed fake data up from sensors and all that stuff. It's this big old heavy thing that you have to implement to make it play like that you have hardware. So to bring the scheduler up. Now I'm saying have to as if I know. I'm basing that upon what I'm seeing in code, but you have to bring up the HAL. You have to bring up the driver station. And I think also bringing up the HAL brings up network tables as well, and maybe other stuff, I don't know. Because again, I'm basing that on work that I'm seeing be done in the tests that WPI are doing. Nicely, one of the authors in WPI created what's called an extension, a JUnit extension. And that's one of the benefits of JUnit 5. You now have this extension architecture that'll run stuff for you even before you run or instantiate class variables on classes and so forth. It's called mock hardware. It's called the mock hardware extension class. Now, the unfortunate thing is that class lives in the tests directory on the WPI suite. So at least currently, when you drag everything down, that test hierarchy doesn't come down. So it's not available to you. It's okay. I can copy and rob it. So I created the correct hierarchy, and I basically just drug down the mock hardware extension as it existed at the revision of the code that I was at, and I just now stick it in my project. Again, one of the things in my ticket, I'm going to say, hey, it'd be really super sweet if you could include this in the stuff that the teams get when it gets drug down. So the way then that works is that you decorate with your class, with the extend with decorator, you basically declare that mock hardware extension class, and then as if by magic, when stuff in here runs, the HAL is spun up, network tables is spun up, everything that you need to run the scheduler, it gets spun up and is available. So the scheduler just runs as it's supposed to. That's cool. Now, back to my test. Because you have the HAL up, you might say, well, hey, go expose your data up through the HAL. I think that's possible. I've actually never done it that way. That's why the HAL actually exists, because you got a simulator there to do all sorts of fancy physics stuff, and who the heck knows what you can do with that. For this test, I don't want it. I don't want that complication. I know what I want to do to the hardware bits that sit in these subsystems. So I'm just going to use Mockito. I'm going to mock it out. So my hardware is mocked out, but everything else is not mocked out. I want to run them. This is an integration test to see if my subsystems interact with each other properly in the context of a command group. So, so I have a digital input that is going to be providing the stimulus for making these things flip. So first thing that I want to do is I want to mock my silencer to return false, which is it's a digital input. Next thing, so here's all of this. I like to call this ceremony. So I'm instantiating my subsystems. Here's my two subsystems. I'm instantiating my commands. I'm instantiating my command group. All of this ceremony you typically see inside what's called a fixture, so that you can repeat this ceremony. Like you could, this test right here it can say hello a second time only after silencing the first. Well, you might think of a lot of different kind of integration tests that you want to try to run, and you don't really want to have to repeat this ceremony all the time. So take it and stick it somewhere else so that you can reuse it. I've only got one test in here, so I've just included it. Okay, so now I have my command group wired up under a variable called class under test. What do? You start the command under test. Usually in a robot program, you don't have to call start, because you're wiring up your commands or command groups hooked up to buttons or joysticks or whatever. But there is a method called start, so that's how you trigger it without having to have it under a button. Next, so now we want to pump the scheduler engine to run execute on the appropriate commands for some duration. And so here's my scheduler, and I want to run for a duration of this is in milliseconds. I got a little comment here that says duration in milliseconds. So I want to run my scheduler for a second. Now, what do I want to do? So I want to make sure that the first LED from the silence subsystem at least flashed once, right? Because I ran for a second, so that first one should be flashing. I also want to check to make sure that the second one didn't flash at all, because it shouldn't have. I've applied no stimulus. My stimulus up here is false. So, usually in tests, you don't want to do a whole bunch of assertions. You're not trying to assert. Your tests need to be very, very small and test for very small specific things. So you usually don't want a lot of assertions. And again, you could break this test up and like build more and more and more integration tests where you don't do these assertions. I sort of just did them all at once for the sake of doing this talk. Okay, now I want to trigger I want to stimulate the outside world. I want to trigger my silencer And now, anytime that's called, I want to return true. So it's like, the digital inputs now has been asserted. Start my engines again. Pump the scheduler another second. Now, final. My first LED, since I'm flashing every 200 milliseconds, and I ran for a second, I should have 5 flashes, 5 individual assertions to that LED to one state. My second LED then also should have flashed 4 or 5 times. Now I say 4 or 5 because my code's not deterministic. There could be some rounding issues or whatever, so I account for that. So I don't have sort of random failures. Okay, that's my test. Let's run it. I'm going to do a Gradle clean just to make sure that I can prime my test to run. Okay, so let's do Gradle test. Now, you'll notice as we sit here and watch the screen, it runs slower. Let me comment about that. So, and I should also mention that all of my tests now, because of, I guess the way WPI changed things up, if you try to instantiate a command outside the context of a robot program, I get stack traces. I haven't really looked into what's stack tracing, but I do think it is because things are not properly wired up. In the alpha version, I only found that one. I was carrying around. If you watched the video, and in prior videos I talked about it. I had a little static block at the top of all my text that was faking out this one high-level usage reporting variable that was complaining because it wasn't set. And when I did that, all my tests worked just fine. That's not the case now in the beta version of beta 2A version. So that's fine, I guess, because I now have the ability through this extends with to bring up all of these foundational bits. My tests now all work again. Okay, that's great. You notice it ran slower. Well, why does it run slower? Because for each and every test now, we're spinning up the HAL, we're spinning up network tables, we're spinning up who the heck knows where. Oh, we're spinning up the driver station, by the way. The driver station's coming up, or at least a fakey version of the driver station is coming up. For the type of testing that we're doing, my preference, if I was the CTO, I would say no. We need a way to. We need a very, very lightweight, totally minimalistic way of doing the minimal amount possible to just exercise commands and exercise subcommands and so forth, because it takes time to bring up all of that heavyweight stuff. And frankly, because again, we're using Mockito to mock up our hardware. We're not going to, at least I don't want to use the HAL. I don't want to have to use all that heavyweight stuff to do that. So, if it were me, I would love a way, I would love a mock hardware extension, ultra lightweight. And all that would do is it would just allow you to run the scheduler. Maybe there would be one called mock hardware extension medium weight, where it actually would bring up network tables so that you could do some system testing. Again, unit and integration testing with network tables would just mean you just want to test whether you're calling to network tables properly. You're not going to go test that network tables actually responded with some value or whatever. But if you do a system test, you might want to do that. So you might want to have a mock hardware extension medium weight class. But anyway, this works fine. I'm super stoked, super happy that this allows me to run all my tests for commands, subcommands, commands, subsystems, and command groups. Now, I talked about the build Gradle at the beginning, what I had to change. It wasn't a whole lot of things, but to get this to actually work, I worked a long time to figure out how to get it going. And it ultimately turns out that the solution wasn't that hard, but figuring out what it was hard. The current version of the beta files that come down include in them debug versions of the HAL and maybe some other stuff, which makes sense because this is in active development. I'm sure the WPI folks and the beta teams are furiously trying to get all this stuff put together, and they're sending down the debug versions. Well, the problem is that I didn't have, and if you read the documentation on the first site, what they say is if you want to build the framework, you need Visual Studio Community Edition 2015. Well, I don't want to build that. I just want to use it. Well, the problem is those dependencies like the WPI HAL JNI, I think it is, has requirements on the Visual C runtime debug version. Yikes. So once I figured that out, then I started combing through Microsoft site to see if you could just download the redistributable version of the debug version. No, of course you can't. At least I couldn't find a place. And by the way, Microsoft, your site is just, oh my gosh, it's so hard to find anything. Please fix that. Personally, I love Microsoft. I love VS Code, by the way. VS Code is just, it's rocking. Visual Studio is a big monolithic behemoth. It's got a lot of neat features in it, but it's so heavy. VS Code is so lightweight. It's so cool. I had Visual Studio 2017 community installed. Did that have the stuff for 2015 in it? Of course it didn't. So I go to Microsoft, try to find Visual Studio 2015. By the way, the first site I don't think had a link to it, so I had to figure out where it was. Got to log on to the Microsoft Visual Studio portal or whatever to even gain access to it. Figure out where the heck that is. Figure out how to download it. Got to click some buttons. You got to go get an entitlement to. It's like, gosh, it's so hard. Eventually, I was able to download it, run it. It says, oh no, you have incompatible stuff installed. You gotta take that off. Of course, they're talking about 2017. So I uninstalled 2017. Try it, run it again. It runs. It's going to drag down 10 gigabytes of junk. Wait 2 hours. It finishes and it says, oh, I didn't finish properly because you still have incompatible stuff. Turns out I had the 2017 redistributable stuff also installed. Uninstall that. Rerun the installation for 2015. Finally, it works. And I go through all that rigmarole, and I tell you that because, if you want to download this project and just run it and, learn a little bit, you will have to have 2015 installed, and, you'll have to go through those hassles and headaches. Now, do I think WPI is intentionally making that hard, making it difficult? No, I don't. I think they may not realize they have the debug builds, or they may not realize that that you have to have, they may not realize that teams are going to try to do what I'm doing, and so the debug build has to be there. The 2015 redistributable has got to be there, and stuff. I'm imagining that they, when they finally cut the final version, they're going to switch over to the non-debug version, and all you'll need is the redistributable, which is easily downloadable from Microsoft's site. So there you go. There's all the stuff that you need to unit and integration test, and your robot project. Now, still though, the robot class is not testable. Well, let me couch that. Because this mock hardware extension works, it may well now be that the robot class is testable. Haven't tried it. Want to try it. Imagine a world. Think back to last year's game. You had autonomous where, you could, depending upon what position you were at, you could drive to the left, you could drive to the right, you could drive around, you could drive to the center. Were you in the center? Think about I remember testing all that stuff. Every time we'd make a change to our game data logic or whatever, we'd have to go we'd have to go stick it in each spot, and we'd have to run the tests. And are you blue? Are you red? Gosh, what a pain. If you had the ability to just write some simple unit tests or integration tests, you could send signals to the driver station, set your game data, and write a test. Did I run the, it should drive forward and turn, right command or whatever? You could automate all that stuff, and it just runs. And so when you make a change, you haven't broken autonomous. Wouldn't that be just a beautiful thing? Well, it's going to be a thing this year with these kind of things. With that, thank you for watching, and good luck.